We're now going to look at example 2 of non-linear sequences. We're actually given the nth term of this non-linear sequence. The reason you know it's non-linear is because n has a power of 2. If n is a power of 1, that's how you know it's a linear sequence, but this is clearly non-linear. So we're given the nth term of this sequence, and it's n squared plus 1. So the first thing I'm going to write down is un equals n squared plus 1. Remember, un is the term value in the sequence. And n, remember, is the term number. And that's what the purpose of this nth term formula is. It connects each term number n to its corresponding term value un. So the good news is we don't have to get it. It's already given to us. Part A then says, write down the first 3 term values of this sequence. So what that means is you're going to sub in n as 1 to work out the first term value. You're then going to sub in n as 2 to work out the second term value, and you're then going to sub in n as 3 to work out the third term value. So let's start by subbing in n equals 1. So the first term is given by n as 1, and then we sub that in to work out what the actual first term is, what its term value is. So everywhere you see n in the formula, replace it with 1. So we're going to get u1. So u1 means the first term is equal to, replace n with 1, put it in brackets because we're subbing in a number that has a power, and then we're adding on 1. So do your powers first here. 1 squared is 1 multiplied by itself, which is just 1. So 1 plus 1 is just going to give us 2. So the first term is 2. What we're going to do now is we're going to sub in n as 2. So go back to your nth term formula, replace n with 2, so we're going to get u2 is equal to 2 squared. Again, put the 2 in brackets because you're subbing in a number that has a power, and then we add on 1. Do your powers first. Remember, 2 squared, anything that has a power of 2 means you're multiplying it by itself. So we're multiplying 2 by itself, so 2 times 2 gives you 4. So that's going to be 4 plus 1 is going to give us 5. And that's our second term in this sequence. Okay, let's get the third term in the sequence. So we're now going to sub in n equals 3. So we go back to our nth term formula and replace everywhere we see n with 3. So we're going to get u3 equals 3 squared plus 1. And again, make sure this 3 is going in brackets because you're subbing a number into a formula that has a power. Do your powers first. So 3 squared, or 3 to the power of 2, means 3 multiplied by itself, which is going to give you 9. 9 plus 1 is going to give us 10. So that is the third term in the sequence. So that's part A answered. We've found the first 3 terms of the sequence. So part B then says, explain why 99 can't be a term value in the sequence. So what we're going to do now is we're going to take the term value of 99. So we're going to replace un, because un is the term value, so we're going to replace un with 99. So we're going to sub in 99 for the term value and try and solve to get n. and see what value of n we get. Now remember, n is the term number. Term numbers can only be positive whole numbers. So if n turns out to be anything but a positive whole number, then 99 can't be a term value. So what we're going to do then in part B, we're going to sub in a term value of 99. So we're going to let un, remember un is a term value, we're going to let that equal 99. So go back to your nth term formula. We're going to replace un with 99, so we're going to get 99 equals n squared plus 1. So we're going to try and solve for n, so we're going to bring the 1 over to the other side, so we're going to change its sign, so 99 minus 1 equals n squared. So we're going to get 98 equals n squared. Now, we want to work out the corresponding term number here. So to get rid of a power of 2 in maths, you take plus or minus the square root of the other side. But term numbers can only ever be positive, so we're only going to take the positive square root of the other side. So we're going to take the positive square root of 98, and that's just going to give us n. Now, if you go to your calculator and you type in the square root of 98, what you're going to discover, if we hit our SD button, you're not going to get a whole number. You're going to get n equals 9.899. So we get n equals 9.899. So n is not a whole number. Yes, it is positive, but it's not a whole number. So because the term number is not a whole number, that means 99 can't be a term value. If 99 was a term value, then its term number would be a whole number. So since the term number is not a positive whole number, then 99 can't be a term value in this sequence. And that's how you prove it.